So, hi everybody, I'm Dinesh Joshi. I'm an engineering manager at Apple. I'm also the project Cassandra project chair on the PMC. Thank you. I just I just push papers. Um, I've been associated with the project for about 6 years now, actively. Fun fact, I really wanted to use Cassandra since 2010. I changed jobs so that I could use Cassandra. And then I got annoyed by some of Cassandra's limitations, so got hired into the Cassandra team 7 years ago. So, with that said, I'm going to talk to you about how you can overcome some of the limitations that we've been talking about in this room in the previous talks, especially what John mentioned is how do you overcome the CPU or garbage collection and memory overhead, right? What you can't do right now with Cassandra is throw 1,000 cores at it. But what if you could throw 1,000 cores at Cassandra and you could process all of the data at any scale that you really want, and your only limit is the network and number of cores that you can actually throw at the problem. And that's the topic of this presentation. I have with me Francisco. I think you have heard from him yesterday about the Sidecar project, and those two projects are interlinked, and we'll see how. So the agenda is we will talk about Cassandra just as a refresher. I know everybody here knows Cassandra, but let's level set. We'll talk about problem statements. I mean, I think we've really covered all of the bases here, like garbage collection, memory, the CPU, disk, IO, everything that is a limitation that prevents us from reading all of the data all at once from Cassandra at large scale. And when I'm talking about large scale, I'm talking about tens of petabytes or hundreds of petabytes of data. And then we'll talk a little bit about the fundamentals of moving data around in Cassandra and outside Cassandra, and then the analytics architecture, and then see how you can get started with using it. So what is Apache Cassandra? I'm going to go really quickly with this. Since everybody knows Cassandra is an open source distributed NoSQL wide column, highly available, linearly scalable database. Right? We all have used it, hopefully, throughout our careers. And it's used at Apple to store petabytes of data. And at this scale, you have a bunch of problems that show up. Right? So let's frame the problem statement so that everybody is on the same page. This is typically any analytical architecture. Like if, since the inception of Cassandra, this was the architecture that was recommended. You have to create a special analytical data, DC, to store data that you want to analyze. So Cassandra allows you to have multiple DCs. One DC is what you use for actually serving your live traffic. So your web services go to DC1. And DC2 is exclusively used to throw Spark workloads. And the reason we did this is because when you try to read data out of Cassandra, one row at a time, which the Java driver generally does, like it paginates and all of that stuff, but it's still not fast enough to take all of the data out of the database. And that's typically what Spark does. You need to read all of the data. This is what was recommended. We want to go to this architecture. Can somebody tell me why this is a better architecture? It's cheaper. It's half the cost. Cassandra, you maintain 2 data centers, sure, you maintain 2 data centers for DR, and that's the cost you have to keep. But what if you don't really want to maintain DR? I mean, that's a different conversation. But the current situation with Cassandra was that we had to create a separate analytics data center in order to actually avoid scenarios where Spark would overload Cassandra nodes. Right? And this is cheaper and better in order for us to operate it. Fewer nodes to fail and fewer nodes to operate. So how do we get to this, right? Or what are the problems that you have to face? So first problem that we're talking about here is that we want to analyze data, all of the data in Cassandra in place. Right? What it means is that you could, in theory, take the data, copy it to HDFS or S3 or whatever your favorite distributed data store is, and then you can process the data in there. And what's the problem with that? That it's a pipeline that might take you tens of hours, or in some cases, in a very large scale, right? It may take you days or even weeks to pull that entire data out slowly out of Cassandra into HDFS. And that's just not feasible at large scale. The second issue is frequently people tend to do bulk loads of data, right? So they have a raw data feed that comes in from various vendors, and you do a bunch of ETL processing, and then you eventually load the data into the data store in order to serve it out. And in order to load that data very quickly, it's we have limited options at this point. And what happens when you do a ton of writes, we were talking about it in the previous talk, is it generates a lot of compaction activity, and then that slows down your cluster. So there are issues with like just using the Java driver to load a bunch of data in Cassandra, like at that scale, obviously. And the third problem is you don't want to bring down the cluster. Honestly, like I can store 1,000 nodes, 1,000 cores of Spark at Cassandra, and I can kill it. You don't want to do that to a 10-node cluster. It won't be good use of your resources. So why is reading and writing data a problem? A lot of data problem in Cassandra. I mean, it's supposed to be linearly scalable and all that, right? I think we covered that today sufficiently. So the TLDR is that the read path and write path, as I would quote John, is not super efficient. I mean, it is efficient, but not super efficient when you go to very large scale. So to summarize, there's a lot of stuff that happens in the read path. And this is not a exact representation of read path. This is a very abbreviated representation of what we are doing in the read path. So don't hold me to the accuracy of this. But it's just to illustrate that there's a lot of stuff that happens on the read path. And if you're trying to read like hundreds of terabytes of data out of Cassandra, doing this billions of times, trillions of times, it's going to cost us CPU, memory, allocations, garbage, all of that stuff. And the coordinator also is in the path. So let's not forget that. So when you do this at scale, it's kind of slow. Similarly, for the write path is also super efficient, but it has a lot of steps, right? Like when you write something, you go to the commit log, you do a bunch of parsing. And one of the things that happens when you write a lot of rows is you generate a bunch of SS tables which have to be compacted together. And that also causes a lot of overhead. So overall, lots of rows is slow, lots of writes lead to lots of compaction. And basically what we see is when you're doing any sort of reads and writes, today, the Spark connector that we have in the open source community, this is the DataStax Spark connector that we have, uses the Java driver. And they actually basically go through the same read-write path, right? So they go to SQL, they do reads and writes through all the serialization, deserialization, and they have to look up things. So that's the part that I really want to frame the problem with, is you're using the same read-write path that the driver is currently using. So how do you solve this? Like, how do you fix this? There are a lot of good ideas, but we needed to fix it immediately. And so going back to this architecture, right? What can we do differently is we invented or we added another process. We already had a process called Cassandra Sidecar internally, and this process is a co-process. It's sitting alongside Cassandra. And we introduced a couple of APIs in that process, which would allow us to stream SS tables out of it, get a snapshot on Cassandra, and read its token metadata so that we know the overall layout of the topology of the cluster and stuff like that. And we also built this library called the Cassandra Analytics library, which has the same classes embedded inside of it, which is used to read and write the SS tables. So basically, serialize and deserialize SS tables using what we call as Cassandra all jar. It's the same jar, but it's just embedded inside this library. So you can imagine where I'm taking this conversation. So what we do is with the analytics library, um, we skip everything. Like we just go to our Cassandra sidecar and say, hey, snapshot this cluster. It creates snapshot. Snapshot it goes around and creates hard links across all nodes in the cluster. And then the sidecar has APIs which say, give me all the SS tables that are part of the snapshot, right? Simple enough. And that just gets zero copied out of the node. And when I say zero copy, it means like you establish a TLS connection. It's not truly zero copy, but what it does is it's not serializing, deserializing. It's just taking the whole file and shoving it up to Spark. The analytics library is basically a Spark job that you deploy, and the sidecar is basically using it, or rather, the sidecar is being used as a side channel to extract all of the SS tables that are part of that snapshot. And what this means is that all you're paying here is the IO cost and a little bit of CPU and memory overhead, but not as much as you would if you would try to read a bunch of rows directly from the Java driver. So yes,
is that JSON or Parquet or what does it come out?
It comes out as a blob. It's the actual file. If you would take the bytes and shove it up the network, that's it. Right? It's a send file call. The kernel takes over and it just sends it to the network driver, and that's it. Right? We don't care what happens. So literally, it's we're not transforming. If you were to transform, that's an extremely high cost of reading data, transforming it, and then writing it out. So these are actually SS table files. So with this, what we've observed is, you can really transmit a lot of files, and then on the receiving end, it's sparse. So it's all up to how much your credit card has on AWS, right? So basically, you can throw 1,000 cores at it or 5,000 cores at it. But there is practically a limitation, because if you are throwing 5,000 cores at a 100 node cluster, it still is, we have to do a lot of IO and network management and stuff like that. So there is a limit to it as well. But we've benchmarked it to up to 30x faster when we read the SS tables out and have Spark actually interpret them. So in order to talk a little bit more about the architecture of how this happens, I'm going to hand it off to Francisco.
All right. Yeah, so let's take a look at what a bulk read is going to do. So if I'm in Spark and I want to do a data frame that read from a Cassandra data source using the Cassandra Analytics library, what this is going to do is on the Spark side is the driver is going to go to talk to Sidecar, and from Sidecar it's going to retrieve like schema information, practitioner information, the token layout of the cluster, and with that information we go back to the driver, and the driver is going to create a snapshot. So the driver is going to talk to each of the sidecars, and Sidecar will make a call to Cassandra to create a snapshot. So we have a snapshot on the Cassandra side. And then the third step is for the driver to partition this partition this layout into different tasks. So we go now to the executors. The executors are going to take these tasks, and what's going to happen is we're going to get a list of files, stable files that we have on disk, and we're going to get the index information, like some information that allows us to read the data. So each task knows what version of this table it has to bring into the process. And then with that information, we stream the SS table. So through Sidecar, from the database disk, we stream it back to the task. And then on the Spark side, we're gonna dedupe or we are gonna do the merge of the different, for example, if we are reading for local quorum consistency, we read from two different replicas, and then we have a merged row, then we convert into a Spark type. And from there, we have a data frame that we can manipulate, and we can write it to a different, like for example, we can write it to Parquet or some other type. Let's take a look at the bulk writes. So again, we have Spark, Cassandra. Similar to the bulk reader, we are the driver is going to talk to Sidecar and get again partitioner information, the schema of the table, and the token layout. And then with that information, we're going to create tasks. So I have some data on Spark, and then I'm going to split this data based on the token layout of the Cassandra cluster. And each of these tasks is going to write SS tables. Write SS tables, we validate that the SS tables are, we don't have any bit flips, so we do checksumming. And then with that information, we ship it, we stream it to the Sidecar process. So that's step number 4. And in Sidecar will do an equivalent of node2 import. So the Cassandra process is going to import it into the process, and the data will be available. So if you do replication factor 3, for example, the task is going to do the upload to every single replica, and then we do the import as we get the data on the Cassandra side. And yeah, that's it. And then we do, at the end of the job, we ensure that we have reached the consistency level that we wanted, and we have data on the Cassandra side. And now you can push data very fast from Spark side to Cassandra. But what happens when you want to do this copy from a Spark that is on the East Coast of the US, and your Cassandra cluster is on the West Coast, for example? Or you can do it. What happens if you have the Spark on the US and Cassandra in Europe? You have to go through one, so that's can be expensive. So this new feature would allow you to move the cost, or move not the cost, but more on the data transport that we are going to use is S3. So what if you have like an S3 compatible transport where you can push all the data through this transport, and then you don't have to worry about these limitations that you may have. So the driver is going to perform the same operations. So we get the schema information, we get the partitioner information, and then instead of pushing the data directly to Sidecar, we push it to S3 or an S3 compatible data transport. And then from there, Sidecar will know that it needs to retrieve this data from S3. So we avoid consuming the one directly. So these limitations that we may have, we can avoid it by moving the transport to S3, and that's how we end up with the data on the Cassandra side. Yeah. So how does this work? So and on the task, at the task level, the task is going to talk to Sidecar, and it's going to signal that it has produced SS tables and uploaded it to S3, and then Sidecar will know that it needs to download this data. So with periodic tasks that are going to check for these SS tables when they become available, it's going to pull it down from S3 and do the import. And this, with this feature, we have failure recovery and rate limiting. And yeah, that was the feature. And getting started, how do you get started with the project? Cassandra Analytics was open sourced recently, and it's part of the Cassandra sub project under Apache. So you will find it in Cassandra Analytics. For this, we need the Sidecar. So the Sidecar is also available under the Cassandra sub project. So it's going to be under Cassandra Sidecar. How do you do a bulk write? In Spark, you have some input data set that you want to write, and you use the Cassandra bulk source. You specify some Sidecar instances that you want to talk to. So this is going to be your contact points of Sidecar. And you specify the key space and table where you want to write, consistency level that you want to achieve, DC. If you were doing local quorum, for example, you need to specify the DC and like authentication against the Sidecar process, and you do the save, and data is written to the cluster, Cassandra cluster. Similarly, for bulk reads, you wanna read data from the Cassandra data source. You again specify some Sidecar instances, key space, a table where you want to read from, the data center, snapshot. We talked about this that we read from the snapshot, and then you load the data and you have a data frame, and then you can do transformations from that data set. And yeah, so you find more information about Cassandra Analytics in CEP 28. And as we saw, we have Cassandra Sidecar and the analytics in open source. You'll find us in the Cassandra Dev mailing list if you want to interact with us. We're working towards the Sidecar release that is going to enable us to release Cassandra Analytics. And yeah, that's the end of the presentation.
We might have the same question. What's the densest node you ran this against?
I can't answer that question.
Okay. And I guess for clarification, it does do bulk export the entirety of the nodes file system to the Spark executors, or is it intelligent and just picking like subset best settings?
So you would run the export against key space and table.
Yeah.
So only the tables that make up that key space and table would be pulled out of the node.
Yeah, but the entirety of
Yes. So if you want to run a very selective query on Cassandra, highly selective, this is not for that. Yes, John.
Hi. Can you, is the analytics library there tightly coupled to the Sidecar, or can you read the data out of S3 directly and bypass Sidecar and just read the SS tables?
So the Sidecar is at this point, the bulk writes are happening. You could use S3 transport, write it to S3, and then the Sidecar actually reads that out of S3. There's no connectivity between the other than the control channel. There's no connectivity between the Spark job and the Sidecar. So yes, to answer your question, the Sidecar can read data out of S3 and restore it on Cassandra.
I don't want to. I want to. My question is more like I want to read the data with Spark directly out of S3. There's no. If I can avoid copying, let's say, 100 terabytes from S3 down to, then have the Sidecar get involved, like I can just save a lot of time that way.
Yeah, so the question was, can we read using the analytics library from S3? So we have an interface in the analytics library has the bulk read has an interface, and there are two implementations. You can do bulk reads from a local disk, so you can have SS tables from a local disk, and the other implementation that we have is talking to Sidecar. But it would be fairly simple to implement another bulk read from S3. So the interfaces are there, and two implementations are part of the project. It's only a matter of like implementing S3 support, which is I think is something we need to have as part of the analytics library.
Well, especially if you have continuous backups, you could avoid hitting Cassandra entirely and just query S3. So replication or not, that seems like the ideal path where you can just go absolutely bananas and like you never.
Yeah, so I think the two features like we need to implement is on the analytics library to read data from S3 and for the sidecar to push data into S3. So those are the two features. Like what we have right now is write data to S3 from the bulk analytics library and read data from S3 and restore it to S3. So what we need is the inverse of that.
Yeah, that would be. I've had multiple teams ask me about that. It would be crazy.
It's only we can only type so fast.
Is there any cost benefit to using the S3 version rather than just streaming directly to the?
I can't talk about costs, but what I can say is when you want to do a fan out, right? Your Spark job, let's say, is in US West Coast, and you want to restore data to like 10 clusters across the globe. In theory, it makes sense to just do the write once and then like process the data in S3 and then tell all of the clusters to restore that data. So one of the features that we are about to open source, or rather we have a ticket to open source, is a coordinated write of some sort from Spark, so that all of these clusters can be restored from the source, which is push only one to S3. So if you have a, in theory, if you have a use case where, let's say, you want to push a lot of data to your edge nodes across the globe all at once, then you can basically leverage this. Yes.
Like at the very beginning of that process, like the Spark coordinator talks to a single coordinator node. Is that like I was kind of confused how the Spark workers know then what to fetch from what data node.
Yeah. So the question was, how does the Spark worker knows where to fetch data from, which nodes to fetch the data from? So basically, we discovered a topology. The Sidecar has a API where you could just ping the API and say, give me all the token metadata, all of the topology information. Again, this is all pluggable interface. So you, in theory, if you had like a config system which has the whole topology, the Sidecar doesn't need to reach out to the cluster. What it rather, the analytics job doesn't need to reach out to the cluster. What it needs to get is the topology layout of the of the cluster.
Got it. Thank you.
Any other questions? Yes.
It's like comment. Like when the data comes out, like is there like there was just like a iceberg talk in the next room. Is there any thought about like kind of like having it publish with like some iceberg table kind of format to describe those files, so it's not just usable by Spark, but other kind of like lakes and things like that?
Yeah, so with a bulk read, right, what you can do is you can get the data out of Cassandra really fast, and then the way the bulk read works is it doesn't like stream all of the data all at once to the Spark node. So as you consume the iterators, the data is pulled out from Cassandra incrementally. So you don't like stream all of the files. But if you want to transform those files into another format like Iceberg, you could just do it very trivially because you could have an output, like you could take the data frame and you could just use the output format as Parquet or ORC or whatever you want and just say save. And then whatever is your destination, whether it's S3 or HDFS, whatever you're using, it'll transform that and put it in this format that you need for Iceberg.
Yeah, it should be trivial. Once you got it in Spark, to go from whatever it is into Iceberg or pick your 3 other formats.
Yeah.
I can confirm that we're currently testing right in Iceberg right now. With that.
Can
We're
you,
current, like our output format is Parquet on Iceberg. We are like currently testing using the mobile system. We have other things we need to make work, but that's is on the company.
yeah, so if we go to the bulk reads, like once the data is loaded, you have a data frame available, and then you connect it to your output, whatever is the sync. So it's like literally in 3 lines of code, you're taking like 100 terabytes of data, moving it from Cassandra into some other format. Right? And the transformers that you're using are basically just Spark nodes. So you can throw however number of cores you want. So if you want to archive the data to Iceberg for your data like use case, you can definitely do this.
Thanks.
Okay. Any other questions? All right, cool. Thanks everybody. Thanks for your time. And
Okay, next one is Birds of a Feather, 20 minutes. But if you want, we can make it earlier. 10 minutes.
Very nice.